Hello. Today we're going to be talking about parallel databases, and specifically partitioning and the handling of skew. To begin, I/O parallelism is the implementation of many disks to faster the process of a single disk. To do this, it uses partitioning to split the data from the single disk onto nodes for the other disks used. Horizontal partitioning is the main process for this, in which tuples from the disks are assigned to individual disks. There is a few data partitioning strategies, and these are used to ensure that each node handles a similar amount of data. To begin these partitioning strategies, we'll say that there are n nodes that are being partitioned, and n to the 1 is going to be used, or that grid is going to be used for the data partition. In a round-robin system, it scans the relations in any order, then it sends the ith node to the node n I minus 1 mod n plus 1. This rotates which position the new node is placed. Hash partitioning creates a hash table that is 0 to n minus 1 in length. Each tuple of the original relation is then hashed with a particular attribute, and if the hash returns I, the tuple placed on node n is placed on node ni to the second. Range partitioning is where you attach the value ranges to each node based on the particular numbers you're partitioning. It creates the vector, which is less than the amount of nodes that is created, and each range is based upon the value of what is received within the vector. When you're doing these strategies, you need to maintain the order of all the nodes and such. When you insert, tuples are just inserted based upon the partitioning strategy. When you delete something, the location is found based on the partitioning attribute, and then it is removed. When you update a tuple, a few things happen based on which strategy. The location is unaffected when you use a round-robin strategy, or if the partitioning attribute is unaffected. In range or hash partitioning systems, however, partitioning attributes do get changed. In this case, the original tuple gets deleted, and an updated tuple is reinserted based on the partitioning system. Access to this data comes from scanning the relation, the location of the tuples associated with point queries, location tuples in a given attribute set are used in range queries. For a round-robin system, it's ideal for reading the entire relation sequentially for each query. This is good for both types of queries. Hash partitioning is best for point queries based on partitioning attributes. An example would be finding the name of a student with the ID number below. This works in about 1 over n the time compared to a single node system. This scheme is not well suited for point queries and answering range queries, due to the need to scan every node. Range partitioning is well suited for both point and range queries due to its ability to narrow down search. This maintains good response time while minimal types in query range. However, execution begins to skew slowly when more are added. Dealing with skew. Data distributed skew is when data is distributed unevenly amongst nodes. This can come from multiple things. It can be attribute value skew, in which the imbalance comes from the partition values that are given. Partition skew refers to a load imbalance that was not caused by the attribute values. Execution skew can happen when there's access to nodes unevenly and some get repeated too often. Balanced range partitioning vectors are another way to deal with skew. This method, you add an additional scan on the nodes in order to balance the distribution of tuples to each node. This takes extra I/O time because you have to wait for it to sort initially. This can be mitigated if a histogram is used and the issues are pre-computed so that you know what things need to be moved around ahead of time. This can be difficult to scale up because it's hard to know how many things are going to need to be changed. Virtual node partitioning is another way to reduce skew. You create more virtual nodes than the regular nodes that are linked to the data. This allows you to separate the workload with the virtual nodes and place them wherever you see fit. The virtual nodes also allow elastic storage because they can be deleted and replaced as needed. Dynamic repartitioning is another way to reduce skew as well. Repartitioning is the act of redoing the original partition. It is extremely expensive because you have to go over all of the partitioning methods that you did before. Dynamic repartitioning does it better with virtual nodes, and it only semi-does the process. Each virtual node gets assigned to a real node. However, if a node is over-encumbered, it can split into two different virtual nodes and send the other virtual node to a node that is less worked. In order to maintain the partitioning values, it keeps a partitioning table. Requests must be made to read the partitioning table with the partitioning key. The table is the collection of all this data. Tables are then broken apart and partitioned into tablets. Parallel data storage systems store partition tables in a master node. That is the end. Thank you.